Today, we're going to talk about a pretty alarming day on the calendar, a day that shows, in stark terms, how we're using up our planet's resources. But this isn't all doom and gloom, because we're also going to look at the incredible ways we're flipping the script, turning our waste into wealth and our cities into actual mines. So, let's dive in. Okay, let's just try a little thought experiment. Imagine you get your entire year's salary on January 1st, the whole thing, in one lump sum. But by the time you get to the end of July, every single penny is gone. For the next 5 months, August, September, all the way to December, you're living on credit cards, just going deeper and deeper into debt. How stressful would that be? Well, that feeling of imbalance, it's not just a hypothetical. You see, that exact scenario is playing out right now, but on a planetary scale. We measure it with something called Earth Overshoot Day. It's the exact date each year when we, all of humanity, have used up all the biological resources that the Earth can naturally regenerate in that entire year. Think clean water, forests, fish, everything. Any resources we use after that date, that's us dipping into the planet's savings, running on pure ecological debt. And this graph, wow, it tells a pretty dramatic story. If you look back at 1970, we almost made it through the year. Earth Overshoot Day landed on December 29th. We were living almost within our means. But just look at that curve since then. We've been dragging that date earlier and earlier, from December to October to August, and now it's happening in late July. It shows our consumption isn't just high, it's speeding up. So, overshoot sounds a bit abstract, right? What does it actually look like in the real world? Well, it shows up as symptoms, and one of the most obvious ones is pollution. It's the direct consequence of us using things up and throwing them away way faster than the planet can absorb and process our waste. Take our water, for instance. The effects of pollution create this devastating domino effect. It starts by degrading aquatic ecosystems, but then it seeps into the soil and harms plants. It can suck the oxygen right out of the water, which poisons animals. For people, it means the spread of really serious diseases like typhoid and cholera. And maybe the scariest part is bioaccumulation, where toxins build up in smaller organisms and get more concentrated as they move up the food chain, eventually ending up right back on our own dinner plates. And of course, it's not just our water. For the very air we breathe, we have a really clear tool to see what's going on, the Air Quality Index, or the AQI. Honestly, you can just think of it like a weather report, but for pollution. It uses this simple color scale, from a nice healthy green to a hazardous maroon, to give us a daily snapshot of how safe our air is to breathe. Now, looking at all these problems can feel, well, pretty overwhelming. But this is where the story pivots. This is where human ingenuity really kicks in. We've developed some incredibly sophisticated, high-tech ways to start cleaning up the mess. Water treatment, for example, has gone through a quiet but radical revolution. The old school way was pretty basic, simple filters and chemicals like chlorine. And that worked, kinda, but it was totally useless against modern problems like microplastics, tiny traces of pharmaceuticals, or heavy metals. Modern treatment is a whole different ballgame. It's smart, it's driven by data, and it's specifically designed to target those new contaminants. And here's the best part. It doesn't just create tons of useless sludge. It actually recovers resources from it, like biogas to create energy or even fertilizer. So if we take a peek inside a modern treatment plant, you can see it's this really impressive multi-stage system. It starts with a physical stage, basically screening out the big stuff. Then it moves to a biological stage where helpful microbes do most of the hard work. And it finishes with this advanced tertiary stage to polish it off. The result isn't just less dirty water, no way. It's clean, reusable water, an absolutely crucial resource. So what's the secret sauce here? Well, it's technologies like these. We're talking about membrane filters like reverse osmosis, which are so incredibly fine they can block microscopic particles. There are advanced oxidation processes that use things like UV light or ozone to literally zap stubborn pollutants out of existence. And the whole thing is getting smarter, with a network of sensors providing real-time data to make everything more efficient and catch leaks before they even become a problem. All right, let's switch gears from water to air for a second. You've definitely heard of a catalytic converter, but we probably don't appreciate just how brilliant it is. This little, unassuming box under your car is basically a miniature chemical plant on wheels, and it's fighting air pollution right at the source, every time you drive. So how in the world does it work? It's this beautiful, elegant, three-step process. First, all the nasty exhaust gases. Carbon monoxide, nitrogen oxides flow into the converter. Inside, they pass through this ceramic honeycomb that's coated with precious metals, like platinum. These metals act as a catalyst, sparking a chemical reaction that completely transforms the pollutants. And what comes out the other end? Much, much safer stuff. Carbon dioxide, harmless nitrogen gas, and plain old water vapor. It's amazing, really. It can eliminate up to 98% of the most harmful emissions. So all this high-tech cleanup stuff is incredible, but it's fundamentally reactive, right? It's cleaning up a mess that's already been made. The next big leap is to be proactive, to completely rethink our relationship with trash, so there's less of a mess to clean up in the first place. And that's where this idea called integrated solid waste management comes in. It's a fancy name, but it's really a total shift in thinking. Instead of seeing garbage as something you just collect and dump in a hole, ISWM says, wait a minute, this is a complex stream of resources that we need to manage smartly. It's about combining everything, prevention, recycling, composting, even recovering energy, into one sustainable system. This pyramid, the waste management hierarchy, shows that thinking perfectly. Down at the very bottom, the absolute worst option is disposal in a landfill. As we move up, we get better options, like recovering energy from waste, and then recycling. But look at the top. The most effective, most powerful strategies are reuse and, at the very peak, prevention. The biggest takeaway here is that the single best way to deal with waste is to simply not create it to begin with. Now, once you really start to see waste as a resource, you get to some truly mind-bending ideas. Like, what if the richest deposits of valuable materials weren't buried deep in the ground, but were already all around us, right inside our cities? This is the core concept behind urban mining. It's exactly what it sounds like. Systematically going through our city's waste streams, especially old electronics and construction debris, to recover valuable raw materials. We stop digging new mines, and instead, we start harvesting the metals and minerals from our own junk. Our cities literally become mines above ground. And if you think that just sounds like a nice idea, get this. This fact is absolutely stunning. A single ton of old smartphones contains more gold than a ton of ore from a traditional gold mine. I mean, just let that sink in for a second. We are throwing away stuff that is richer than what we're digging out of the earth. This isn't just good for the environment. It's a huge economic opportunity just sitting there. Okay, so we've been talking about these big global concepts, overshoot days, urban mines. But how does this all connect back to us, to our day-to-day lives? How can we measure our own little piece of this enormous puzzle? Well, the most common yardstick is our carbon footprint. You've heard the term a million times. But all it really means is the total amount of greenhouse gases that are produced because of our activities, from the car we drive, to the food we eat, to how we heat our homes. And this isn't some vague, abstract number. It's totally measurable. The basic math is pretty simple. You take your activity, like, say, using 50 liters of gas in your car for a month, and you multiply it by a standard number called an emission factor. And boom! In this case, you get a footprint of over 115 kilograms of CO2. Just from 1 month of driving, it makes our personal impact very real, very tangible. So here's where we land. We're living on a planet with a finite budget, and yeah, we're pretty deep in ecological debt. But we have the smarts and the technology to turn these massive problems into incredible solutions. We know how to turn our wastewater into a resource, our exhaust pipes into air purifiers, and our cities into the richest mines of the future. The ideas are there, the technology exists. So the real question becomes, what will it take for all of us to put these pieces together and finally start shrinking our footprint?